I've finished the last video having created the course and course engagement types. In this video, I'll finish this setup code by creating my student class. I've got the project streaming students up from the last video, and I'll create that class now. The first thing I'll include is a static long to help set my student ID assignments and call it last student ID, setting that to 1. I'm also going to set up a private final static random variable that I'll use for all the randomization I want to perform when I create random students. For my instance fields, I'm going to make them all private and final. I've got a student ID, a long, country code will be a string. Year enrolled is an int and will be the year of the first enrollment. Age enrolled is an int, the age of the student when they enrolled. Gender is a string. And I have a Boolean for programming experience. I've also got a map of course engagement records keyed by the course code, a string. I'll instantiate it here as a hash map. It doesn't need to be ordered. Next, I'll generate a constructor that includes all the fields except for student ID from the list there. I'll insert a new line after gender. I'll add a variable argument for courses so I can set up a new student with one or more courses. In the constructor, I want my student ID to be the value of the last student ID, and I'll increment that static field after the assignment occurs. Since courses is a variable argument, I can use it in an enhanced for loop, which I'll do next. For each course passed in, I'll call an addCourse method, which I'll be implementing in a moment. I'm going to pass the course and also a date. I can build a date from its parts, meaning year, month, day, using localDate.of. In this case, all students will get enrolled on the first month of the year and on the first day. Next, I'll create the addCourse method, so this code compiles and that'll be public and void. It'll take a course, I'll call that new course, and a date, enroll date. This has an entry to the engagement map keyed by course code. The map value is a course engagement instance, and that takes a course, an enrollment date, and an engagement type, which will be enrollment to start. I also want an overloaded version of this method that doesn't take a date. I'll put this one above the other on line 36. For this one, I'll pass the current date to the overloaded method. Next, I'll generate a bunch of getters, all public, because this is the data I'll be using for many of the stream code samples coming up. I'll generate getters for every field except the first one, the static last student ID. I want to rename the getter name for is programming experience to has programming experience. I'll make a change to the getEngagementMap method because I want to return a defensive copy. I'll return a copy of the engagement map using map.copyof. I'll add getters for some calculated fields that'll be useful. I'll start with a method called getYears since enrolled. This returns an int. It returns the years between the current year, which I'll get from localDate.now, and the enrolled year. After this, I'll add getAge, which also returns an int. This one will return the enrolled age plus the years since enrolled. Next, I need a method that will give me the elapsed months since the last activity. It should return an int, and I'll call it getMonths since active. The parameter is a string for the course code. I'll get the course engagement record from the map using course code. I'll use a ternary operator to avoid a null pointer exception, so if the course wasn't found, it'll return 0 months. Otherwise, I'll call the getMonths since active method on the course engagement record. Next, I want to get the overall months since active, so this has the same name, returns an int but doesn't take any parameters. In this method, I'll first set up a variable and int inactive months. I'll initialize this to the maximum number of months possible, getting the current year and subtracting 2014 and multiplying by 12 to get months. Any activity for a student should be less than this number. I'll loop through each key of the engagement map for each course code. I'll use another static method on math called min. It gives me the lesser of the two numbers. This means I'll get back the months elapsed for the most recent activity. I'll add one more getter method on this class, a method called getPercentComplete. The course engagement class has a method of the same name, so in this case I'll invoke that. The parameter will be the course code and the method will return a double. I'll use the course code to get a course engagement record. If that doesn't exist, I'll return 0, otherwise I'll call getPercentComplete on it. I said in the introduction slide that I wanted a method called watchLecture that takes a course code, a lecture number, and a month and year for the date. This is public because you can imagine a course management program calling this code when a student logs into a course and listens to a lecture. I'm passing month and year because these will be randomly generated. I'll get the activity record from the engagement map using the course code. If I found an engagement record, I'll call watch lecture on that, passing it the lecture number. I can construct a date from the year, month and day one and pass that next. I use one as the day because I really don't care about days in the code ahead. After this, I want to generate a toString method using all the fields. I went through this code to set up student pretty quickly because it's a bit tedious to set up all the getters and so on. I've written a lot of code without testing anything yet, so it's time to do just that with some code in the main method of the main class. I'll create a PYMC variable for the Python master class with a course code of PYMC. That has the title Python Masterclass. I will do the same for the Java course, so JMC, with a course code of JMC and Java Masterclass for the title. I'll create a student Tim, a new student, and country code, AU, for Australia. The year enrolled is 2019, and my age I'll say was 30, and M for male. I'll say true for programming experience, and the last argument is the variable arguments so I can pass in these two classes, and I'll print that student out. Running the code. You can see I've got a lot of information there. The student ID is 1, and the student demographics are there, country code, year enrolled, age, gender. Tim is signed up for 2 classes, and right now the only engagement is enrolment. Both happened in January of 2019, and there is the months elapsed in square brackets after that. I'll next call the watch lecture, first for the JMC course. I'll send it lecture number 10 in the 5th month of 2019. Then for the Python Masterclass, let's say Tim watched lecture 7 in the 7th month of 2020. I'll print the Tim instance out again. Running this code. The course engagement records are reflecting the additional data about what the last lecture watched was on each course. The student class has a lot of different data elements on it, and I planned it this way so there'd be a lot of diversity in the kinds of things we can do with this type in our stream pipelines. The last thing I want to do is create a public static method on student that will generate a new instance populated with a lot of random data. Before I do that, I'll create a little helper method that picks a random item from an array of strings. This will be private and static and return a string. I will call it getRandomVal and it'll take a variable argument of strings. This will return an element from the array using the index picked. It'll call next int on random, passing the length of this array as the upper bound number. I'll now create the getRandomStudent method, and that'll be public and static. It returns a student, and the only data it will take is a variable argument for courses. First, I want the maximum bound for any generated year. This will be the current year plus 1. I'll create a new student. I'll first pass a random country code from a short list using the helper method I just created and passing a list of country codes. I'll pass an enrolment year between 2015, so the first year I started offering courses. After that, I'll use max year, so this will give me a year between 2015 and the current year inclusive. Next, I need an age, so I'll make that between 18 and 89. To get gender, I'll use getRandomVal with 3 possibilities, M for male, F for female, or U for unselected. I'll generate a random Boolean for the programming experience flag. Finally, I'll just pass the courses straight into this constructor. I can get a random student with this data, but I also want to create some random course activity, and I'll code this next. I'll loop through the courses that were passed. For each course, I want a random lecture number. I want a random year, but it should not be less than the year enrolled. I'll get a random month. If the year I got back is the current year, I need to make sure the month isn't ever greater than the current month. If it is, I'll just set it to the current month. I'll execute watch lecture. This will update the engagement record for this course with some activity other than enrolment. Now I'll get back to the main method and use streamsGenerate method to create as many random students as I need. My Lambda expression has no parameters, it's a supplier, so it supports no parameters, but that doesn't mean I can't pass arguments to the method I want to call. In this case, I'm going to call the static method getRandomStudent on the student class and pass it my JMC and PYMC variables. These have to be effectively final, which they are. I will limit this to 10 random students at the moment, and I'll print each student to see how each looks. Before I run it, I'll comment out all the code above stream.generate except for setting up the 2 courses. Running this. You can see I get 10 students back. Your own data will be different, of course, but now we've got students with plenty of variety in the data, and that's what's going to let us have some fun with this. That's it, we're ready to put some stream operations to work. I don't know about you, but I prefer tangible things to work on, so that's why I took some time with this code. Abstracted code is good for small examples, but it's much easier to explain use cases with realistic application code. The next video is a challenge, which uses this code to test what you learned about the first set of terminal operations I covered. See you in the next video.